All right, friends, welcome to the Azure AI 900 Fundamentals Workshop. Just want to say welcome there. Really excited to have you guys. My name is Will. I am an instructor on the data science team. I was formerly an instructor for the part-time accelerated team, so the web development. So I've got my hands in both, so I understand where you guys are coming from there. And then any students that come from the data science side, I also understand sort of what you guys have done and where you've gone. So just welcome there. Before we get started, just a little bit of ground rules. We're going to be working in teams today. So teamwork makes the dream work. Making sure that we're honoring people and their views and their thoughts, having humility, right? I don't know everything about the cloud. I don't know everything about AI, right? Nobody does. And so I'm going to do my best to make sure that I give you everything that I have. But if there is a question I don't know, I'm always happy to dive into that with you. And I'm not going to just, say something that necessarily isn't true. Especially this one, you guys have been around the dojo. Strength through struggle is a massive piece of what we do. And it's because you have to get your hands dirty for you to really reinforce learning. There is going to be a portion, like I was talking about earlier, that is about machine learning. And if you've never dealt with machine learning on the outside, it might seem a little bit more difficult. And so it might take a couple iterations for you to really understand the pipeline, but that will reinforce your learning. So as always, strength through struggle, and then respect for myself and for your colleagues, that if I'm talking or if somebody else is talking, we ask that you, if you have a noisy background, just stay on mute and, sort of respect people and when they are speaking. Here's a little bit of a modified schedule. Usually I break this down till about 12:30 because this morning session is much heavier from a information perspective. And it sometimes depends on questions. We usually are done around noon. So, but we do have a 30-minute buffer. Then we'll have an hour lunch. So if we are done at noon, we will be come back at 1 o'clock. So if you guys are planning to pick up kiddos or anything, anything in this afternoon, just wanted to give you guys an update. We will likely be going till about 12 is generally when we end. And then we'll have lunch from 12 to 1 PST. And then from 1, we'll pick up. I've never gone to 5 o'clock. Usually it's about 3:30 or 4. I've never gone to 5 o'clock, but we block it off just in case there's lots of questions, or maybe we as a class move slower. That's okay. So it is blocked off till 5, but again, I've never gone there. So in this workshop, we're going to learn about some core AI concepts. We're going to learn about different workloads and pipelines that the Azure AI services and Microsoft Azure has. And so once we do this, you'll be prepared to take your certification exam. And we're going to talk more about that a little bit later. But once you have this certification, it's a really great thing to showcase on a resume, on your LinkedIn. LinkedIn is great because when recruiters look for people or they have a requirement for Azure or cloud, right? If you have the certification, it shows recruiters, this is great, right? This person is more advanced in this topic, because if we're being honest, sometimes recruiters also don't necessarily know anything about the cloud. There's this really funny post that somebody put was on their website. They put up, or on their LinkedIn, sorry, they put a bunch of different languages, right? But then they also put a bunch of Pokemon, and they asked recruiters, like, tell me which ones are Pokemon, because recruiters sometimes are known for asking for a bunch of stuff. But by having this on your resume, it will help you stand out whenever they are searching for people for jobs. And right here, I did send the slide deck. I'll send it for anybody that has just joined. But if you were curious, there's a market research piece that you can follow this source, and it will take you to it to show you how there is an uptick in Azure developers. Azure has the most data centers of any cloud provider in the world. And so there is a big uptick, and people are loving Azure and going towards it, especially lately. A couple times AWS has been down, and so that's not great for a company. So there's some learning objectives here. Our learning objectives are to prepare for the AI-900, so it's going to be specifically geared towards preparing you for that exam. There is going to be some general learning, but again, it's going to be some questions, and I'll be pointing out different kind of study strategies or different things you can do to prepare for that certification. We are going to learn what AI is and the core concepts of AI. And we are going to learn, and this is where it's Azure specific, the Azure specific offerings for different types of AI. So like I was saying before we started class, a lot of these cloud certifications cover a general concept of AI or, of the cloud or of data, right? But then each certification, whether it's Azure or AWS or GCP, does also focus on specifically that company and how that company handles data or AI or the cloud or something like that. Somebody in chat did say that's the same link as earlier. Yes, that is the same link. It was for anybody who joined after I sent that message. That way they had access to them as well. Cool. After completing this as well, you will get a 50% discount. So let me just make sure that there's solid understanding there. Whenever you complete this, and that is for the majority of the day. Now, if you do have something that, we're going to go till 3:30 and at 2:30, you've got to go pick up your kiddo or, so you have a doctor's appointment. I fully understand. I'm not going to, if you aren't here till the last second, you don't get one. No, as long as you're here and you participate for the majority of, all of the morning and the majority of the afternoon, I'm okay. If you have some sort of unique circumstance, you will receive a 50% off voucher. Now, this value of this 50% off is $50. Now, you can use this voucher on any Azure workshop, but please know that there are other workshops that cost more than $50. And in that case, or more than $100, because that's what the AI-900 one does. If you use this coupon, it's not going to be 50% off of your certification. If it does cost more than $100, it's just a $50 saving. So let's say you want to take the AI-900, use this certification, it's 50% off because it gives you $50. There's other certifications that might be $150 or $200 off. It's still just gonna be the $200 value or the $50 value. It's not going to be 50% off the higher price certification. So just to be aware there, it is worth $50, and you can use this coupon on any of the certifications that Azure offers. So it doesn't just have to be AI. And so there will be an exam. We'll go through how that exam looks towards the end, and I'll show you the Learn platforms soon. But there is a platform that Microsoft has that reinforces and goes a little bit more in depth of what we're going to do. We've taken the Cliff Notes and we've taken the exam and the Cliff Notes of everything and consolidated it to where you've got about 90% of what you need. There will be a little bit of learning on your end to reinforce ideas or to just memorize some certain pricing stuff. Other than that, though, you should be really, really, really set up well. So we've taken all that knowledge, done the dirty work, and then gotten you here. And then you'll take that and you earn this badge. This badge is basically a certification. This is what you'll put on your LinkedIn. This is what you'll tweet out, all that good stuff. It is good for 2 years. So you don't have to get certified for another 2 years. And so just to know that the certification is not for life, but it is a 2-year certification, which is awesome. A little bit about the exam. You're going to have 90 minutes to do it. It's going to be 50 to 60-ish questions. Now it varies. Typically, we see about 55. That's what students report. But I have had students that had 50 and I've had students that had 60. Typically, it's 55, but it's somewhere in between that range. It is proctored. So you do need to schedule that in advance, meaning that it's not just going to be, it can be done from your home, which is really great. But it is not just you fill out this certification or you fill out this multiple choice thing and then you send it in and then it's, oh, you passed or not. It is proctored, meaning that there is somebody watching to make sure that you're not Googling. You can't use outside resources. You do actually have to show your desk, make sure that you don't have other resources or another laptop that you can Google questions and then, put them on or look up the material and then put it on and answer your question. So it is proctored in that way. That might sound intense, but it actually is what gives validity to your certification, right? LinkedIn, badges are great. And it's good that people are extending their learning, but you can Google every question and you can, it doesn't certify that you know this knowledge off the top of your head. But the certification, by it being proctored and you not being able to use outside resources, does verify that this person does know about the cloud. They do know about AI and they do know about the offerings of Azure specifically. So it does actually enhance your verification and your certification. So it's what gives validity to the actual certification itself. For the test format, this comes directly from Microsoft on their website. And so this is how it's broken down. And this is how we're going to tailor our workshop. So we've got workloads and considerations for AI. It's about 15 to 20%. the majority of this morning is going to be on the fundamental principles of machine learning in Azure. And so that's that pipeline I'm talking about. If you've never dealt with machine learning, that's okay. We're going to go from the beginning and we're going to sort of explain machine learning from a high level. So that way you understand what a pipeline is and how machine learning works and the different workflows that we can have there. Then that'll be the morning, the first two. Then the afternoon's the real fun stuff, in my opinion, where you start dealing with computer vision and you can see what you can instantly apply to your code, what you can instantly do, whether it's computer vision and computers reading faces or images, or you can use natural language processing, which is, speech to text, or, creating your own virtual assistant, and then conversational AIs, which is like bots, right? You've all probably called into a company and then they had a bot that either was on the phone or online, right? That says like, I'm here to help you. And then it just has a list of questions that you can pick from. And that's that. So you can instantly apply those to your website, which is a really cool thing. So that's the breakdown for the actual exam itself. And right now we currently offer 3 different certification programs at Coding Dojo, the ones that are free workshops. We've got the Azure Fundamentals, which is actually tomorrow. So if you guys aren't doing anything, there is an offering tomorrow. All of these are monthly as well. So for Azure Fundamentals, obviously this is the AI-900. And then next week I will be doing the DP-900. You can go to all 3 of these and you will receive a 50% coupon for each one of these as you go there. Now this does say web development and data science. I would say that AI is a nice hybrid of both. I think even the DP-900 has some elements of web development. And I think anybody that's a data scientist would get a lot of stuff from the Azure Fundamentals because it goes over actually what is the cloud, how does the cloud work and operate. So all 3 of these I would say are great for both web development and data science. And then here, like I was talking about with the extra certifications, are things that you can do as well. And you can apply your coupon to any one of these. You can only use it to like a one and done coupon sort of thing. But here are all the different offerings currently from Azure that they offer from a certification standpoint. Again, this is a learning path. This comes straight, and this is what we will be handling. This is what Microsoft suggests the learning path to be, where we deal with workloads, we deal with machine learning, NLPs, computer vision, and conversational AI. And we're going to walk through that step by step, piece by piece. Just wanted to give you a little bit of resources. So here, if you already have the slides, you can click on this, but I'll put this in the chat as well. But here is the place where the material lives for Microsoft. So if you were to go here, this is their Microsoft Docs. You can create an account and it can follow through. You get badges and fun stuff to mess with. But here is where you will actually prepare for the exam. You'll prepare for the different learning paths. Here you can schedule your certification. So you would schedule it with Pearson VUE. That's that proctored exam. That's what you're going to do. And we'll talk about that at the end. But you can also learn more in-depth things when it comes with NLPs, when it comes to AI fundamentals. So if there is something that was a little bit foggy whenever we walked through it, here's a great, here's the learning paths from Microsoft that's more in-depth. This is a 3.5-hour, 4-module setup that is helping you explore data and using the Azure Machine Learning Designer. So it's a little bit more in depth. If you did want to go that route, if you were struggling with a topic, it is there for you. And then there's all the different paths as you set it up. So you have access to those. Again, here's our tentative agenda. So we will be doing our introduction. I'm almost done with that. Like I said, I'm building quite a bit of time for the introduction. That way, in case there's questions, in case there's any sort of clarification from the certifications. Then we're going to have an intro to AI, where we do a group exercise where we talk about responsible AI. We'll have a little break this morning, just because we try to break it up to where it's not just me talking the entire time. You guys are in groups, you guys are having breaks, and there is a little bit of instruction as well. And then this portion right here, this machine learning portion, is going to be, just a heads up, this is going to be our heaviest portion of the day, where it's going to be a lot of information, a lot of me teaching. And then we'll go into a group exercise where we'll do this. This first one will break up into groups. And then the second one, we will do this as a group. Then we'll head to lunch. I did want to also offer this. You do not have to do this. It is not required. It's just something we created just in case you wanted to do this. It is just a study guide that you can, it's for your own studies, that if you wanted to answer what these are, or it's just a way for you to continue to, grow and have this as you are studying for this exam. Now, you won't be able to edit this because this is our copy. So as always, what you want to do, anything I send you, if you can't edit it, you just come here and you say, make a copy. When you make a copy, that is now going to be your copy. And then you can edit it and you can change different aspects. If you wanted to write down questions or answer questions, et cetera, you can do that here. Just go here, file, make a copy. Cool. Any questions on that? Any questions on the certification process? Any questions on the actual exam itself? In the chat, can you guys put a 1 if you're good and a 0 if you're if you have questions? Somebody did ask, I'm attending on my phone. Will I be able to participate while in the group exercises? Yes, to an extent. If you have Google, you'll have to read some links that I send. So as long as you can do that, and then you'll just have to ask somebody to basically create a doc maybe on theirs or share something like that there, but you should be fine. Okay. So before we get started, I do like to also, in the actual teaching portion, I like that you guys, I like to have banter between you guys, or else it's just me talking and that's not fun for anybody. So can anybody tell me what is Azure? Anybody want to take a guess? You can come off of mute. You can put it in the chat. What is Azure? Anybody have any ideas? Any guesses?
I don't know, guys. Would it be okay if I say like I feel like the Azure is like big Wi-Fi, right? So you have like two antenna, two radars, and you have created some kind of environment where you have your like data centers running and providing some services for the whatever company looking for deploying your programs, your software, I mean, that's what I would do.
Yeah. So, I mean, you're exactly right when you said that it's data centers that people can use, right? It's servers that Microsoft owns. And somebody in the chat said Microsoft version of AWS Cloud is exactly that. It is a spot where there are something called data centers. And again, Microsoft has the most data centers of any cloud company in the world. And all these data centers basically have a bunch of servers, or you can think of them as computers where you can deploy your project. You can utilize some of these storage tools or anything like that, right? If you guys did the belt exam on the web development side and you did a black belt, you had to deploy, right? In AWS, basically what you did is you SSH'd into a server, you pulled some GitHub code and you put it out to where anybody can go to your project. Same sort of thing. Microsoft Azure is that, right? Microsoft Azure is those data centers. They're actually connected via cables, which is sort of crazy. If you attend the AI-900 tomorrow, you'll see the internet is all just cables, which is sort of nuts. Now, Elon Musk is starting to do Starlink where it's all satellite internet, but currently now everything is connected via cable, and they're in the ocean. They go from, New York City to London. There are cables, fiber optic cables that go in the ocean, just sit on the floor of the ocean. That is what connects our internet. So when you're connecting to a server in the UK, it's all just going from a cable down. It's just sort of nuts. But yes, it can be, somebody else said, it's a cloud for storage and deployment. Yep. So you can use this for storage and deployment. There are other things that Microsoft Azure also has as tools, right? So not only is it like a computer you can use, but maybe this computer has certain applications or certain things that you want to use as part of that. It does allow you to do that. But from Wikipedia, it says Azure is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers, which is exactly what we just talked. So thanks for the participation there. Does anybody know what AI is? Any shots at AI? Anybody? Artificial intelligence, Skynet. That's funny. Yeah, AI stands for artificial intelligence. And what it does is it enables us to build amazing software that can improve healthcare, enable people and overcome physical disadvantages, which we're going to see in a video here. It can empower smart infrastructure and create incredible entertainment experiences and even save the planet. So AI is this massive tool that we can use to do a ton of different things. There's a great video here that I want to show. Give me just 1 second. Make sure that I'm sharing my computer sound. Got it. And let me pause this real fast before we get started. Cool. And
artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful.
oh, sorry. Seems like Microsoft's video is not. Let me redo this because there's supposed to be actual video portion.
Artificial intelligence isn't coming, it's here. It's the defining.
Uh-oh, Microsoft. What are you doing, you knucklehead?
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
Sorry, friends. I'm not sure why this is not working. You're supposed to be seeing cool stuff.
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful.
I want the exact same information that my hearing.
Sorry about that, friends. It is a great video. I'll see the link. Maybe you guys, maybe it works on yours. So let me put the link in the chat. But basically, it was just a cool video that let's see, this YouTube video.
Artificial
there we go.
Intelligence
Thank
isn't
you.
coming. It's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses Seeing AI,
I crept down the
I
stairs.
crept down the stairs and out the door.
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change,
We can use technology to help feed the world without wrecking the planet.
enabling wildlife conservation,
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
and creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare
And now you can see these finite details, the relationship with many structures.
to engineering and telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first.
The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box.
No.
Microsoft AI empowers others to create experiences and potential. This is just the beginning.
Artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
Well, Winter, thanks for coming up clutch and doing that for us. I really appreciate that. Not sure why that link didn't work. Maybe it's my browser. Yeah, I'm not sure. Anyways, cool. So that's what AI can do for us. So simply put, AI is the creation of software that imitates human behaviors and capabilities, right? So you guys have heard of maybe machine learning, and that's a portion of AI. Now, there's actually some key elements of AI that is not just machine learning, right? There's machine learning, which we've talked about and we're going to talk about. That's where we can train our model to make some sort of like predictive analysis, right? So Zillow is a great example, and I'll use that quite a bit, where we can put in, or you can put in maybe your square footage, your zip code, number of bedrooms, and number of bathrooms, and maybe year that it was built. And Zillow will predict your price, right? So that's called predictive analysis. That's a big push in machine learning. There's also anomaly detection. There's computer vision, and we're going to talk about these all in just a second. Computer vision, natural language processing, and conversational AI. So from a Microsoft perspective, these are the 5 key elements of AI. So just make sure that you remember these are the 5 key elements of AI from a Microsoft perspective. Again, machine learning is often the foundation for any sort of system, and it's a way we teach a computer model to make a prediction or draw conclusions from data. Now, there is still this teaching aspect when we're talking about NLPs and conversational AI, but this is going to, when it comes to machine learning, it's really deciding this predictive analysis. In that video, it was talking about farming, right? And we can predict how many people we're going to need to feed, but then also it does stuff like taking weather data, right? And weather patterns and actually deciding how much water a plant needs based off of the humidity, the temperature, the weather pattern, and when it's going to rain next. So we can use all this to make predictions that actually it's not going to rain for another 5 days and this plant needs water now based off this humidity and this temperature. So we're going to give it X amount of water. So there are machine learning models that do stuff like that, which is really, really neat. Then there's also anomaly detection. So that's the capability to automatically detect errors or unusual activity in a system. A great example of this would be with your credit card, right? There's not somebody sitting there watching every single purchase on your credit card. And then if something weird happens, them saying, huh, this is different than what Winter normally does. Let me reach out to them, right? And so what we've been able to do is train computers to say, okay, Brendan just made a purchase in Seattle, Washington, right? And then an hour later, Brendan made a purchase in Russia. Well, one of those is not normal, right? And maybe Brendan typically lives in Seattle. All their purchases are in Seattle. Okay, then maybe that's an anomaly and we should do an alert that their card was leaked or something like that. And so that we can train computers to do that and continuously run and monitor our cards. That way, if there is, somebody tries to buy something in a random state at a random gas station or something unusual from what we are typically buying, then it can detect that and then, kind of give us an alert. Is this you? Did you buy this? And if not, they can shut it down and prevent that from happening. Then there's computer vision. So that's the capability of software to interpret the world visually through cameras, video, and images. This can be big with like automated driving, right? With Tesla and being able to detect people and detect stopping and red lights. That's all computer vision, which is pretty sweet. Then there's NLPs. That's a capability for a computer to interpret written or spoken language and respond in kind. This is a really big tool that we have whether it comes to translation software, whether it comes to like a Siri, Google and Alexa, something of that nature. Tons of NLP processing. And then lastly would be our conversational AI, which is capability of a software agent to participate in a conversation. There's different tools, whether it is us trying to pay a bill and it's the pesky, bot that is sort of limited. And, we're like, I just want to talk to somebody. And they're like, well, let me help you because I'm a bot. That, or even up to, people can now schedule appointments by just shooting a text and saying, text, this number, text the number or text the word appointment. And then it'll ask you what day you want. And then it'll send you the available times of that, hair person or just any general available times. And so those conversational AI bots are just there, and it limits the interaction that you actually have to have with the company, and it makes it more efficient, right? To where you don't have to call in and ask somebody, you can just send a text and at your convenience text back, and then it's good to go. Now there is a large portion of responsible AI. And this is something that Microsoft is really passionate about, is responsible AI, because AI is powerful. And it can be greatly used to benefit the world, whether it's through people hard of vision or seeing or translations or so many cool tools. But like any tool, it's got to be used responsibly. Because with these really powerful tools, we can see that it can actually be shifted and be a form of control or something that's not totally great. And Microsoft, there's a great example that we'll talk about as we go through these responsible AIs. But Microsoft believes that AI software development must be built on 6 different principles. And these principles are designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. So when we're using tools with AI and using tools Microsoft believes, or in creating applications utilizing AI, there are 6 principles that Microsoft believes that we really should be guided by when we build. So this is going to bring us to our first group exercise. Are there any questions before we get started? Any questions on what we've talked about so far? Can you guys put a 1 in the chat if we're good to go to move on? Perfect. Thank you. Okay. Somebody asked, what would be the most common use case for Azure in businesses? So it totally depends. There's a lot of people hosting on Azure. So similar to AWS, there's hosting for Azure. And there's different tools. We're going to see in the afternoon, there's different tools that a company might use. So there's like a form receipt API that somebody can upload their receipts and it automatically gets stored. Everything is read on the receipt and you can put it to different things. So like you think of a company who's got a salesperson, right? That they go out and they are buying customers' lunches consistently, but you're wanting to track and almost quantify and identify what is typically being spent. Is this person predominantly spending it on alcohol or really expensive steaks, or, you know, sort of what is going on there? So there's a ton of different tools utilizing this stuff for AI. You know, we saw, and we're going to see continually, there's this thing called Luis when we get to NLPs that people can use for video games. So there's actually a pretty large sort of threshold for Azure, from something as similar as hosting a website application to something as large as building a video game using this thing called Luis, that can automatically detect what the gamer is using for AR, VR. So it's a pretty large spectrum for Azure. Great question, Winter. Cool. So what I'm going to do is I'm going to put this exercise in the chat, and what this group exercise is going to be is I'm going to split you up in 2 groups. And so what you will actually do, and so what you'll do is each group's going to be assigned, or each person in the group. So because we only have 2 groups, we're just going to do that. But each person in the group is going to be assigned 1 core principle of responsible AI. So in your group, just decide, you know, who's in charge of fairness, reliability, privacy, inclusiveness, transparency, and accountability. So, you know, identify, or somebody pick like, I want to be fairness or accountability, XYZ. And what you'll do is you'll go and you can make a copy of this. So you don't have to, but you can make a copy of entire presentation, and you can either make a new slide, or you can write it down on Google. That's okay. Like a Google Doc, or however you choose to do that. So you don't have to make a copy. We're not going to present the slideshow. What we're going to present is, you know, I'll just walk through and say, you know, who had reliability and safety, teach me, you know, let's talk about that. And then let's spur some conversation. So that's how we'll do it. But what you'll do is, if you do have fairness, let's say in your group, you do have fairness, what you'll do is you'll click this material and it will send you to this doc like this, where it's redirecting you. And you are going to learn about fairness. You'll talk about fairness, and there's typically a video. So if you're on fairness, talk about a video. And then there's some questions in here that you can add more about it. So make sure you include, so you want to teach your classmates about fairness. Basically, what is it? And then what is one real world example of how this is applied? So you can, you know, go as in depth as you want, or, you know, just answering what is this question, and then give at least one world example. And that's for every single one of these. For reliability and safety, teach us about it, give us an overview of it, and then give us a real world example of how that's applied. Are there any questions on this, on what we're doing here? Cool. Well, then I will. All right, friends, coming back to this responsible AI, what we're going to do now is just walk through. And since we had 2 groups, the idea is that 2 people would have, you know, like there's going to be 2 people who focused on fairness, So if somebody wants to speak up, talk about fairness, and then we'll ask if the other person has anything to add. That's kind of how we'll go through each one. So from that, does anybody want to speak about fairness? Does anybody want to talk about fairness? Who did fairness?
I did fairness. I don't mind talking.
Yeah, that'd be awesome.
Yep. So fairness, it's about, making decisions without bias, biases based on, gender, race, age, nationality, things like that. And in AI, it's about making fair predictions too, to make those decisions and to leave out the biasness. And with Azure, it has the capability of interpreting models and quantifying each feature of the data that influences the model's prediction to exclude biasness.
Yeah, that's awesome. Do you have a real world example of maybe where fairness would come in?
Yeah, applying for a loan for a house, or a loan for anything, a business, house, where perfect. The balloon when we had the recession and they had the balloon mortgages, whatever. It was directed to a certain type of people where they knew that it would explode. So it was unfair practices that helped cause that.
Yeah, no, and there's a couple of these that are like fairness, inclusiveness, that are very similar, like synonymous, but there's one, and so great job. Thank you for speaking on that. There's one example when it comes to fairness is it's pretty contested, but I think it's in Wisconsin. There is a county that actually has an algorithm that will basically spit out a number that says if somebody should go out on bail or not. So they take all these different things from, what crime they committed, and it basically, this algorithm created a probability of how likely they were to be a repeat offender. And so if they were super likely to be a repeat offender, then they would say actually they shouldn't go out on bail, or their bail's super duper high. And if they were less likely, then yeah, they could go out on bail because they're not necessarily, an issue to society. But if you think about this, and you even just think from a high level, yeah, it is nightmarish. And there's a lot of contention, and people are like, this is unacceptable. Because if you really think about even the data, and this is an overarching conversation with AI, is your AI is only going to be about the data, as good as the data that you provide it. And it's no secret in America that data from people who are incarcerated is skewed drastically, right? Just higher levels of, Black Americans are in our prison systems than white Americans. Like that's just a fact, right? We know that. And so then whenever you start training this model on who's the more likely to repeat offend, if there's already a higher likelihood of a certain ethnicity, right, then whoever is that ethnicity, if a new person comes in, they're going to say, oh, this person's more likely to repeat offend based off of all the other cases I've seen, but it's because those are already skewed. And so with this, it's a lot of people fight it, and it's still a work in that people are still fighting and saying, this is unfair. This is not fair. This is not setting up anybody correctly, because these parameters that you've set up are already skewed, because your data for US business, or for like US incarceration rates, are already skewed. Like the data in itself is biased. So therefore, no matter what you create is going to be biased. And so this idea of fairness is, how do we create tools, and do we create a tool if inherently it's biased, right? If the data we have is biased, is that tool good for society? And is it fair? Which obviously I think we all would say that, no, that's unfair, yet it's actually in practice right now. So it's a great example there. Cool. Anybody else yeah. Did you want to add anything?
No, just wow, man. That's a hell of an example. It's just wow.
Yeah.
Thank you.
Yeah, it's heartbreaking. And it's, and this is not, another example would be, I don't know if you guys have seen Black Mirror. It's a wonderful show on Netflix. It's sort of creepy because it sort of predicts a lot of the stuff, but one of the episodes, it has like a social capital number. and it's really fascinating. Everything you do is based off of this social score, and it's linked to social media. But there actually is a social capital number that has been instituted in China to where people do have, there's cameras everywhere, and they use facial recognition technology to basically give you a social score. Now, it's not like widely accepted yet, but the idea behind it is that eventually you will be able to get a house based off of this score. And in Black Mirror, it's the same thing. You only qualified for certain housing if you were a certain level of your social number. And behind that fairness is like if somebody's going to a bar every day, that actually inhibits their numbers because there's a higher likelihood that maybe they struggle with alcoholism, right? And so this idea is in our technology inherently, is it fair? And B, does it create, if we're creating this tool, does that cause for fairness as well? Which is just a fascinating concept. There's tons of stuff with AI, and it's sad, but tons of stuff that you can actually look and say, oh, we always think of AI as these really cool things, predicting stuff, predicting climate change or predicting stock prices. But, and I only tell you these things to sort of note and say, like, there are some really, really terrible things that AI can be used for. So that's why Microsoft is really, really adamant about responsible AI. For the other person that did fairness, do you have anything to add there?
I think he said he's at work, but he typed out his notes in our chat, and then I have his notes. I could read them out loud.
Yeah, you want to do that? Thanks, Brendan. I appreciate that.
Yeah, sure. This was Marky. I think I said the name right. I'm not sure. Sorry if I didn't. He said fairness in AI is about avoiding and or removing bias from data sets so that those who are using or are affected by the AI system being used are not put at a disadvantage in regards to other groups of people. That means that AI is used to allocate opportunities, resources, and information, and should not take into consideration information such as race, gender, or ethnicity. For example, so that all have the same chances to receive access to the same resources. And it's also necessary to have a greater diversity of people on teams who develop AI to help limit the bias back into the systems, even if the bias is unintentional.
Yeah, I think that's super well said. And that's something that sort of in the world of AI, there's a lot of contention too. I love that idea that teams need to be diverse in order for AI to be diverse. There's a really popular story about 2 years ago, Google had like a task force within Google that they wanted to see how basically fair their AI was. And one of their doctors, who was a doctorate in artificial intelligence, came out and said, hey, actually, this is we have biased AI. And she was a woman of color, and she got fired. And then came out and, Google was like, oh, actually, we don't have any biases. And so it was this really fascinating conversation in tech that really highlighted, okay, so the person who was affected by this, a woman of color, right? And the biases were against, she was in a demographic that maybe was biased against, then got fired for pointing out the bias. And so there's this push in AI, and there's a lot of pushback and a lot of frustration and lawsuits, right? We need diverse teams in tech. You have to have diverse teams. So I love that you said that, because, and I love that idea of, we have to make sure that our data in itself is not biased. We have to, and that's part of this fairness, is before we even create something, we have to look at the data and say, is this inherently fair? Or even is our data biased? Because if it is, then that's not something that we can use, sort of thing. Again, like incarceration rates. So good job. Next one would be reliability and safety. Anybody want to speak on that?
Yeah, I can talk about that.
Yeah, thank you.
So reliability and safety is basically making sure that any product that you're actually making and pushing out there to the society to use is actually good for the society. And I'm going to talk about the reliable part first. So basically, like a product that can describe to be like a reliable product is basically a product that can basically work and do like the things that we expect it to do. And I will probably take as an example a Tesla car, for example. We know that the Tesla car basically can drive by themselves in United States, but for a car like that to actually be able to work, it has to first understand the whole like circulation process in the United States first before we can claim that, oh, this car can actually drive by himself. And the cool part about that is, for example, the same circulation process that we have in United States can be different from the ones you have in Europe or China. And therefore, like all those cars need to actually, understand and learn how the whole like process work in those different places before they can get pushed to the society. And I'll be giving also like an example for like a bad or like a non-reliable product can actually a consequence of a non-reliable product can actually be bad for the society, because a car that can claim that, oh, I'm able to drive by myself but cannot actually do that is actually a non-reliable product, so therefore we cannot trust it. And now let's jump into the safety part. Basically, a car, once you create like something, for example, that is doing a specific task that you actually expect it to do, it's very important to like make sure that it is safe first. And that's the reason why we basically like do a lot of tests before even like sending a product inside the society. Because, for example, a product that is actually safe for like a 30 years old person, for example, might not be for like a 2 years old or like an 80 years old person. So again, for this part, I would take like an example of like a Tesla car. When Tesla has his car actually working before, he has to do a lot of tests with those cars first. And then after multiple tests, he has to release like a better version of that and have even like tester test the same product in a real life situation before even like releasing like the real product itself. So after all that, you just make sure that your product is kind of safe for the whole society to actually use. And therefore like there's like no problem for your product to actually be used like a daily. And an example of like a non-safety product might result in a lot of problems and in different category. It depends on where your product is being used. Again, for an example of like a Tesla car, for example, if a car like that are not actually safe, we will be seeing like countless accident every single day in the whole world, which will be actually crazy. So yeah, that's basically what I have regarding the part of reliability and safety.
Yeah, absolutely. I think automated cars is something that is a great example. Another one would be, and so well done, Sergey. That's really in depth. Those are really great. Another one would be even from the safety perspective. A couple of years ago, I don't know if you guys, I think it was probably 2020, and there's so much going on, but there were 2 plane crashes from Boeing, right? And if you really think about it, what it was doing, and they said that the issue was that there was autopilot, and autopilot was detecting there was an error in the detection of autopilot from the altitude side. So it felt like it had to nosedive to correct itself, right? And so because of that AI, and there was that idea of safety, and it had a glitch in there that was making it nosedive, because the technology made it nosedive, hundreds of people died, right? And so this is something that, again, I think you said it exactly, is we have to make sure that these are reliable and safe, because those are 3, they weren't the ones that flew across the Atlantic. It was, I think 2, I can't remember where they were, but I think they crashed on land, but Malaysia is where I think it was. But they both crashed, and it was because there was an error in the technology. And so it is just this idea of, that's a great example of when technology, AI is great, but we have to make sure like these people on this plane don't get a second chance. And so that's why Boeing was in and is in a hot mess still, right? Because their technology cost the life of people. And so we have to make sure anything that we're building that we are reliable and it's safe, right? Before, just like you're saying, I love that iteration of, okay, so we build this autonomous car. Now, before we even release it, let's keep testing it. Let's keep making it better to where this should be a once in a lifetime issue that a car malfunctions, not two planes closed immediately because it was a network patch or it was a software patch that needed to be made. That's that there's no room for error when it comes, because if you think about it, right, something that is crazy is if there's 1 million people and it's a 99.9% chance that it's accurate, that's still like 100,000 people. Is that, or yeah, I think it's still 100,000 people. No, I think it's 10,000 people still would be the ones who die, right? Whatever 0.1 of 1 million. Let me do that real fast. And that's, 1 million times 0.01. Yeah, 10,000. So even at a 99.9% chance, 10,000, that somebody's going to survive out of 1 million people, that's 10,000 people will not. So we have to have the most incredible AI if we're going to deal with something like that. So great job. On to privacy and security. Anybody want to talk about privacy and security?
Yeah, I can say a few words.
Yeah, that's great.
All right, so what I've got so far from the Google, so the Azure provides some kind of like way to protect and secure your data, right? So whatever like server we might rather use to use data, so we let like Azure know that we have only this way to run our data. I mean, that's what I've got so far, right? And plus on the top of it, you might have like pick out of 60 regions, wherever works for you, like in terms of place, right? And then security, to protect your security, you might pick like some security service from the AI, which is security posture management service, to prevent some data leakage, to restrict the data administrator access, restrict the user access. So that's kind of things I've got so far.
Right. Yeah. No, I think, and remember, these are tools. So when we build our AI and when we build our programs, these are things that we must keep in mind. One example that comes to mind when it comes to privacy and security was a couple of months ago, Apple announced that they were going to be, it was like a 3-horned system, but one of the big things was if you were on a family iCloud plan, if you had children on that, so people under the age of 18, what there would actually happen is on the iPhone, there is a machine learning model, right? Just in our actual phones itself. And what that would do is it would actually go through all of the images on your phone and see if there was any underage inappropriate pictures, right? Of children or kids under the age of 18.
Right.
And it would detect if you did have that. Even to the extent of if you were a family, if you were on the family plan, if you had a child, let's say I had a daughter at the age of 16 or 15, anything under 18. If that child were to send a photo, an explicit photo to somebody else, I would get an alert that my child sent an explicit photo because it was basically the machine learning model was reading the image and detecting if that had nudity, if it had inappropriate content in there. And on the outside, that sounds like an interesting concept. But people went into an uproar because that's an instant thing of you're going to go through all of my photos. And, the technology that Apple said was like, nobody sees your photos. The machine learning model can't actually see your photos. They explained how it does it, but it still was this instance of that's not private. You're going through all of my private photos, my private things. There was the iCloud leak years ago where a bunch of celebrities got their private photos leaked and it became a big deal, right? And so this idea of privacy is sometimes we do try to create things that are well-intentioned, right? To crack down on inappropriate photos from children. But even in that, we have to remind, like, in the way that we do that, is that still protecting people's privacy and security. So I think that's a fascinating example that really pushed back. And then because people pushed back, Apple put a pause on that and said, actually, we're going to hold off on doing that for right now. So privacy is huge.
Thanks.
Great job. Cool. Inclusiveness. Does anybody want to talk about this?
I could take this one.
Yeah, thanks, Winter.
Hey, so inclusiveness is about being intentionally diverse and inclusive in the approach to AI. This should be remembered in both teams producing the AI as well as the AI products themselves. A couple of examples, like broadly speaking, would be any sort of speech to text or text to speech capabilities. This could be anything from closed caption auto generation to, I believe it's called natural language interpretation. So that way then like the readability of it reads like a human and not like a machine. And also can interpret like voice commands from someone as a human would speak and not a machine. And there's also visual recognition technology such as eye tracking and scrolling, which is really important for those people who might not be able to access like traditional keyboards and mice. And then also another important part that tends to kind of be the crux that kind of like causes things to happen, where things get overlooked is including people that would use a certain accessibility technology in the developing and testing of those technologies, as opposed to sort of addressing it after the fact. One example that I found was that in automated speech recognition, there was a discovery in 2020 that there's a racial disparity in terms of how things are pronounced. And people have been having the resort to kind of like speaking in a more like traditionally like white American pronunciation in order to be understood by certain AI because of the data pool that they were using. So not having people who don't like, who aren't just like white Americans speaking included in the conversation and development of these applications meant that now we have a lot of these robust systems out there that may not be able to interpret people as they wish to be interpreted.
Wow, that is an incredible example. Do you have the link to that? I would love to use that for future thank you. Actually, that's a great example. I would love to use that for future inclusiveness examples. That's great. I mean, that blows my mind that's a really great example of people having to associate to one certain thing because our data is based off of, white English, basically.
Another example of that too is I think in some countries they have different dialects based on like region that also gets in the way of that as well.
Yeah, no, that's a great example. Really great example. Thanks, Winter. That's awesome. Anybody else have anything on inclusiveness? We got two more. Okay. Transparency. Anybody want to go to transparency?
I can do transparency if you want.
Yeah, that'd be awesome. Thanks, Val.
Yeah, so I don't really know too much about AI, but when I went to their website, it was talking about the 2 goals of transparency, which is to mitigate unfairness with using the AI systems, and the other one was to use it to try to gain more trust with users and trying to use AI. And what it's talking about, there's 2 parts of transparency as far as Microsoft AI sees it. That's that creators should be open to what they say, how and why they're using it, and the limitations of the system. And that people should be able to understand the behavior of AI systems, like how it acts and what it's actually doing. Now, as far as I could understand this, real world kind of application that I saw this was read something about the California Privacy Rights Act, which is something that's focused on data collection and right to know, if the data is being collected and whether or not you can delete it or not. And I was reading this one article from Caltech that was talking about the idea of Alexa and Siri, how they use now natural language processing to figure out what you're saying, to give the directions to do what you want it to do. And they're talking about the idea that people are wondering, whether or not Alexa is actually able to record conversations, even though you're not talking to it, since it's always having to parse what you're saying. So it was talking about how this act was born out of those types of ideas.
Yeah, and actually Amazon did announce that they did have recordings and it was listening because Alexa would listen even though you wouldn't activate it. Yeah. So it's great. Yeah, exactly. It's this idea of companies need to be transparent about what they're doing. That's a great example with Alexa coming out and saying like, yes, we actually have been recording and using that to improve our NLP model. Things like you can think about it with Facebook, with the Cambridge Analytics, right? Where they ended up coming out and finding that Facebook was actually promoting certain rhetoric on Facebook because it had more clicks and, you know, conspiracy-esque stuff, and on both sides, right? So that's not a political statement. On both sides, where Facebook was promoting that and promotes different things that are like pro Mark Zuckerberg, or, you know, other things like that, which is a really big issue. And this idea of transparency is people want to know where their data is going and what's doing. And in Europe right now, there's a real big cut down. Even Facebook and Instagram just threatened last week to no longer operate in Europe because they're saying like, hey, you can't do what you're doing with our data. You can't do what you're doing with people in Europe. And so, you know, Mark Zuckerberg said, well, then we won't have Instagram or Facebook. And Europe said, okay, like good, fine, that's fine. Don't have your or Facebook or Instagram because what you're doing with our people's data is not okay. And California is actually the first state to institute that, which is fascinating because if you think about California, it's the largest state in terms of population, and then LA is the number two. I think it's the number 2 largest metro in the nation behind New York, and then Dallas. And so if they are creating these rules and parameters, actually it's going to be fascinating to see other companies try to start following that and going to their rules, because they wouldn't want to, you know, have one product for the rest of the nation and then one product just for California. You would go, because California is such a large market, you would do that. When it comes to transparency, another one you see, another real world example would be with TikTok 2 years ago in 2020, 2019, is there's a lot of, I don't know if you guys have a TikTok. It is the most addicting thing I've ever been part of. I downloaded it for 2 days and said, I can't do this. But they were collecting so much data, and people were sort of like deconstructing and backwards engineering TikTok and finding how much data it was actually collecting. And even compared to Facebook and Instagram, it was infinity more data that it was collecting. And that's where this idea of somebody had in the US had to buy it, and Oracle came in, and it was all because of what is your algorithm doing with our data? What is your algorithm doing? How is it working? And there's a lot of contention because people are like, oh, like, yes, how does this work? How does this group us together, XYZ? So it's really fascinating. Cool. Way to go there. Thanks, Val. Last one would be accountability. Anybody want to take a stab at that? And we'll do our first break. So anybody want to take a stab at accountability?
I can go.
Yeah, thank you.
I feel like accountability kind of encompassed everything we've already talked about. So developers and designers of AI-based solutions should be working within a framework of principles like the ones that we've already discussed, so that the solution meets clearly defined legal and ethical standards, either in place within the company as well as international guidelines. And this needs to be implemented throughout the entire process of creating this AI-based solution. And the developers and designers also need to understand where the responsibility of the software or tool ends, because they might not have any control over how the software is used by an external source, like another company or a client or user. And they also need to be accountable that the outcome of their solution produces fair, legal, and accurate results. So one example that Microsoft was talking about was with facial recognition, and having accountability over that, because if they don't implement these principles, it could interfere with people's civil liberties or in some other unintended consequences.
Yeah, way to go. Thank you. There's 2 real big examples with accountability that I think are just an interesting way to think about it. First one would be accountability. One of the ideas is if you are Tesla, who's accountable if a car, let's do a hypothetical example. You have Tesla, you have autopilot, and it's driving, and your car is driving, and somebody, instead of crossing on the crosswalk, jaywalks, right? Which technically is illegal in the US. And they jaywalk and your car hits the person. Well, who's accountable for that issue? Is it the person who created the technology? Is it the person who sold the car? Is it the driver? Or is it the person who technically broke the law and jaywalked, right? And where does that accountability lie? And so from Microsoft's perspective, the idea is that accountability is something that we as the developer need to hold, right? And it needs to be everybody's accountable sort of thing, to where we really need to be accountable for what we create. We can't really wash our hands. And a great example of people just washing their hands of that is there's this company, I think it's called BlackRock, and they're an Israeli company. And they created this software called Pegasus software that has been used to basically infiltrate people's phones, and they can know where people are at, who they're talking to, who they're calling, get all sorts of data. And it's a lot of contention because companies will get hired or will hire BlackRock or buy the Pegasus software, license it, and then actually track journalists around the world, not necessarily just in the US, but track journalists from all over. And there's a lot of contention because they will come to the companies and say, hey, your technology is being used to, attack and target journalists who have actually ended up dead, right? And their big thing is, well, it's not me. I'm not using this. I'm not doing that. That's not how it's created. I'm not in charge of how X company uses my technology. And the argument is like, yeah, no, you should be, right? And you can't really claim that. They do, and they technically have the licensing to where it washes their hands of it, but it's a big point of contention because they've created a technology that they know is being used poorly and to attack and to target people. So they need to be accountable for their technology. So that'd be another example of accountability. Cool. Does anybody have anything else to add on this? All right. Well, perfect timing. We are going to take a 15-minute break. Thanks for participating in this. We're going to take a 15-minute break, come back at 11 o'clock PST, and then we will get started. We're going to have our AI portion, and then we will, which is, again, sort of our heaviest portion, where we're going to learn all about AI. And then from there, we will go straight in, or sorry, not AI, but machine learning. We're going to learn about pipelines and how machine learning works and the different aspects, features, everything like that. We're going to give it just a crash course in machine learning. And then we'll go to lunch. So we'll be back here in 15 minutes. All right, friends, welcome back. We are now going to dive into just an overview of machine learning and what that looks like. We've talked a little bit about machine learning, and we're going to talk more in depth about machine learning, but machine learning is a foundation for most AI solutions, whether it's an NLP or conversational bot. Machine learning is going to be typically play a piece in every sort of AI solution. And it's kind of dumbed down. It's the process of a computer understanding patterns in data in order to learn and make predictions. Whether it's, if we say something to Alexa, it understands patterns and then, understands what we're asking it to do. And then it does that, whether it's playing a song on Spotify or to check our packages or, to turn on the lights, something like that. That's all machine learning, and it's recognizing patterns and whatever data we give it, and we can give it different types of data, which we'll talk about. This technique does use mathematics and statistics to create a model to predict unknown values. And so there is a piece of that. Now with Azure, thankfully, you don't have to understand that in order to use it. And that's more of a data science-esque piece. Even in our data science course, we talk a little bit about the actual algorithms itself, but a lot of these are just classes or libraries that we can bring into. But here's a great video. Hopefully this one works. Let's see. If not, it's probably my browser. It's not gonna work. Why is this? Let me try it. Try one thing. Sorry, friends. Wondering if it's my browser. I use a browser called Brave, talking about data privacy, and it has given me lots of issues, or it hasn't given me lots of issues. I'm not sure why this is happening. This isn't working either. Let's download it real fast in English. Oh, Winter, I don't know then why it's not working for me. LOL, I don't know. Not sure, friends. Sorry, these videos are not working. I'm on a Mac and I've never had issues until now. But it's just talking about Microsoft AI. Mac users. Yeah, I don't know what it is. Oh, I think I figured it out. Let's try it one more time. Sorry, friends, for the delay here.
Right now.
Oh, it wanted to do it and it didn't. I don't know what's going on. Sorry about that. Yeah, maybe they are sabotaging because I'm on a Mac. Basically, it's about AI and the different things that we can use with machine learning. We can predict food. It's similar to the video earlier today. I was thinking it was because I have like a VPN that was in the UK because I was watching BBC this morning. Alas, that was not it. So not sure what it is, but that's okay. It's not necessary to what we are doing. And I will try to find another solution. Okay. So for machine learning, let's just dive into it. So let's say we have an example. This is an example of machine learning and things we can do with it. So suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflowers using a phone app, right? So we want people to go out using our app to identify wildflowers. Well, if we were going to do that, here's how that process would work from a machine learning standpoint. A team of botanists and data scientists will collect the samples of wildflowers. The team's then going to take each sample and label it with the correct species. So it's going to take a sunflower and say, this is a sunflower. It's going to take, the different pieces. It's going to take that labeled data and then we're going to process it through an algorithm. And the algorithm is going to find relationships between different features of our sample. So with the sunflowers, big yellow petals. And a rose has maybe thorns and is a certain color. So it's going to find similarities between each of those. So that way it can learn, well, this is a rose and this is a sunflower. The result of the algorithm is going to be encapsulated in a model. And you guys, I'm sure, are aware of what a model is. So we're going to create a model to where it is encapsulated in that. And then when new samples are found and when new pictures are given, then we can, generate a new picture. And then it's going to go into a model and say, okay, this has thorns and is red. Okay, this highest probability that this is a rose. So let's spit out a rose, right? So that's how machine learning from a very basic standpoint works. And this is actually an app. My mother is from Texas and I live in Seattle, Washington. And so the PNW, it is beautiful. We have all these flowers and it's very green. There's water everywhere. And when she came to visit, we were walking around this great place called Snoqualmie. It's this beautiful waterfall called Snoqualmie Falls. And she had a phone and did exactly this. Her app, and she loved it, is she would take pictures of plants and it would tell her what kind of plant it is. And then it would give her information on that plant. And, this is this grows here. This is the type of plant this is, et cetera, et cetera. So this exact machine learning model is something my mother found so much joy in. So I'm grateful for that. Winter said that there's also a bug app that does the same thing, which is kind of cool. And I'm sure would be really helpful is this poisonous? Is this, or venomous? Is this, I don't know, poisonous, I guess would be the correct word. You know, is this going to hurt me? What kind of spider is this? Would be a really great example, because you might have an issue. I used to live in New Mexico where there was black widows and brown recluse everywhere, right? And so it'd be really good to know, like, is this a family of black widows coming to potentially kill me? Cool. Now, when we're dealing with machine learning, there is two types that we really focus on in this. There is a third type called reinforcement learning, which we aren't going to talk about today because it's beyond the scope of today's material. We're not going to, it's not on the exam, so it doesn't necessarily matter. The two that you need to know, the two types that you need to know are supervised and unsupervised machine learning. And within supervised, we have two more types. One's called regression and one's called classification. So just know that there are two types of machine learning models for this certification. They're supervised and unsupervised. And within supervised, we have two different types, one called regression and one called classification. And you'll see, we'll talk about the difference here in a bit. Let's try this in a new tab. Let's see what this does. I'm going to hope.
Machine learning is a technique in which...
Oh my goodness. I don't know what is going on. Sorry, friends. I'm not sure what's going on with my videos. If you guys have all videos you click on are on YouTube, by the way. Yeah, if I don't have those currently, but you guys should have the slides. So if you do, I don't know if they work for you. Can you guys, I mean, if you have the slide deck, does it work for you? They do? Okay. Well, I'll put the slide deck one more time if you guys don't currently have it. But take some time, maybe at lunch, watch the videos if you'd like. They're interesting. I don't know why it's not working for me. I'm using Brave and I'm not sure why, but they're not working for me. So this past video just really breaks down machine learning. And so, oh, here's this. This one's important to learn. Oh.
Machine learning is a tech.
Still not working for me. Dumb. Okay. There's the video for anybody in the chat. But you guys usually what I do is I show the video and nobody knows what it's talking about. And then we talk about it and then rewatch the video, but just rewatch the video at the end when we go to lunch, and then you'll be able to understand a lot more of what it, and sort of use it as a test to make sure that you are familiar with those words. Cool. So supervised machine learning, when we have a data set with a labeled target, we can build supervised machine learning models to predict the label. Now, a couple things there. When we're talking about a labeled target, that means we know what we want to predict. So this is our crash course in machine learning. We know what we want to predict. In our house example for Zillow, we know we want to predict the house price. Whenever I am dealing with, let's say, if I was going to pass a test, right? And I took in some information on how much the person studied, how much they slept, how hard the test was maybe, and I want to know if they were going to pass or not. The thing that I'm trying to discover is called our labeled target. So this calls it a label. You might hear it as a target, like if you were to deal with actual machine learning in another realm, but Microsoft calls them a label. That is what I'm wanting to predict. So the columns we're trying to predict is the label, and the columns we're using to make our prediction is called a feature. So in my example of Zillow, if I'm using bedrooms to make my prediction of a house, the bedrooms itself is a feature, and the label is the thing I'm trying to predict is the price of the house. So again, I jumped the gun. Say we're trying to build a model to predict price. This is again my house price. Price is a label, right? That is what I'm trying to predict. That's my target. That's my label. And the things I use, like bedrooms, is a feature. My square feet would be a feature, right? So these things, and including bathrooms as well, would be a feature. Now, when we're dealing with actual machine learning, we can choose which columns we want, and we don't have to use every column of our data set. We can choose certain columns because we don't want to, if we use too many columns or too much, It's called overfitting our model, meaning that it's harder for too much data sometimes, makes it harder for our computer to actually find patterns. So we want to make sure that we have accurate and correctly fit models. But for right now, what you need to know is the thing we're trying to predict is called a label. The things we're using to make that prediction is called a feature. And I said that there were two types. There's regression and there is classification. Now, when our label or our target is numeric, so think of like a house number. If you're trying to predict anything like how much a car is worth, like Kelly Blue Book, how much a car is worth, anytime it's numeric, that's what we're trying to predict. It is what we call a regression problem. So remember, anything, if it's a number, it is a regression problem. And if we're trying to predict a group or category, right? Is the person going to pass or not, right? They're in a group of either people who passed or people who did not pass a test. That's what we call a classification problem. Another example would be if we're trying to predict if somebody has diabetes or not, right? That would be a classification problem because you're in two classes, whether they have diabetes or they do not. Now, one thing to note is with a classification problem, and it can get a little bit confusing, is sometimes our target or our label is in two groups, 0 or 1, where 0 represents they do not have diabetes and 1 represents they do have diabetes. So what's happening is we're using these features to predict a 0 or a 1, but that is still a classification problem because 0 and 1 just represent a group that they're going into. It's not an actual numeric value because it can't be anything more than 0 or 1, right? It's not a 0.5 or a 3. It's just it's predicting one of two classes. Does that make sense? So sometimes, even if it's predicting a 0 and a 1, the 0 and the 1 represents a group. So therefore, it's still a classification problem. Anybody need clarification on that? You put a 1 in the chat if that makes sense. Perfect. Great. You guys are smart. Okay, so when your label target is a group or category, that's what we just talked about. It is a classification problem. So say we're trying to build a model to predict the price. Is this a regression, classification, or clustering problem? You guys can put it in chat or come off mic or come off mute. What right here? If I'm trying to predict the price here, yeah, it's regression, right? Because it is a numeric prediction. We're trying to predict a number. Cool. Say we're trying to build a model to predict passing an exam. What would hours studied be? What is that called? Hours studied. Not regression. Remember, what am I trying to predict here? What's the question asking? Yeah, VJ. We're trying to predict if they're going to pass an exam. So they come in one of two categories, passed or failed. What am I using to make that prediction? Hours slept, homework, and hours studied. So if I'm using hours studied to make my prediction of passing an exam, then it would be a feature. Great job. Say we're trying to predict passing an exam, what would score be? What is that called? What am I trying to predict? What is this column called? Yeah, it's called a label, right? This is my prediction is a label. So score in itself, that column is a label. Great job. And then lastly, we're trying to predict this. What type of problem is this? Regression, classification, or clustering? Yeah, classification. Great job. Let's just go over that one more time just to make sure, because especially if this is brand new and you've never dealt with machine learning, what we're using to make our prediction is called a feature. So in this case, our study is a feature. The column we are trying to predict is called a label. And then the type we're trying to predict for this one, because it's in two groups, either passed or failed, this is called a classification problem. Great job. So those are supervised, right? We know what we want to predict. It means that it's supervised. We have an idea of what we're trying to predict. That is supervised. And if it's a number, it's regression. And if it's a group or category, it is a classification. But when we have a data set without a labeled target, let's say I have a bunch of data and I don't necessarily know what I want to predict, I can actually do unsupervised machine learning and create an unsupervised machine learning model. And when I do that, the main task of the unsupervised machine learning is clustering. And so for this certification, all you have to worry about for unsupervised machine learning is clustering. Now, there is another one for unsupervised called dimensionality reduction, which is an unsupervised task, but it's beyond the scope of this exam. We do teach it. If you guys are ever interested in the data science course, we do teach dimensionality reduction. But for this exam, it is clustering. So again, when we don't have a label of what we're trying to predict and we want to create a model, it is unsupervised machine learning, and it does something called clustering. And clustering is the process of grouping together similar observations, creating clusters of similar data points. Our computers do this by using unlabeled data, meaning we don't know what we want to predict. So we don't know what the right groups are, and we just rely on patterns in the data to discover new groups. Somebody asked in the chat, is R or Python taught in data science course? We use Python strictly. So what does that mean? Unsupervised machine learning says, let's say I have all these data points right here. It's going to find the data points that are similar, and it's going to group those together. It's going to cluster them into a specific group. So say we're trying to build a model to group our customers into similar groups so we can better individualize marketing. And this is my data right here. It's age, customer sense, and then follows. Do they follow us or not? If I'm not trying to predict anything, right? I'm not trying to predict, are they going to pick this or whatever. I just want to get my data and I want to group them similarly, right, to similar data points so that I can target them differently with my marketing. Somebody asked in the chat, maybe I missed something. What is the difference between supervised and unsupervised machine learning? Supervised is when I know what I want to predict. I have a label, right? I want to predict a house price or if they're going to pass or fail. Unsupervised is I don't have a label. I don't know what I'm trying to predict. I just want to group up similar data points to accomplish something. In this case is to better individualize marketing. So if I were to do this, this is what we call a clustering problem. And we'll talk about this more in just a second. So let's say I run this model and I have this data right here. Or I've got my 24 and 31-year-old person. Okay, they're a group. I have my 43 and my 49-year-old person. Okay, they're a group. And then I have my 55-year-old, right? Which is sort of in their own cluster. This is important because what happens is when we cluster them together, maybe I then say, I want to have a marketing campaign for my 24 to 31. That's about the millennial age. And millennials typically are on Instagram, right? That's like the millennial social media that most millennials have. Now there is TikTok and other things, but I'm going to do advertisements to this clustered group. Let's say that there's 100 different accounts. I'm going to advertise to these people on Instagram. Right? That's where I'm going to get the most use of my marketing. Now, this other group, this 43 to 49, that is Gen X. They might be more Facebook. So I'm actually going to do Facebook marketing to this group. Then for the 55, maybe they're actually paper marketing, right? To where I'm actually going to send out a flyer to them because that's how it would best use them. They don't necessarily, they're sort of a new customer. They don't follow us. They're not really on social media. Okay, I'm actually just going to send them a leaflet because that's how they would operate. So now from a marketing perspective, I'm not wasting my money in just doing one advertisement on Instagram only because that's not going to hit, you know, these three ones. And I'm also not just going to do Facebook because now I'm missing out on customers. It allows me to individualize my marketing so that I can better get people to buy my product. Now there is a great example, and I just want to show means clustering visual. This is a great example of how K-means works. It's a visualization. It doesn't have any sort of audio, but here we start with data points, right? Let me make this full screen. Here we start with data points, just like what we had. What we then do is we create what we call centroids. And so I want to say, I want to have three groups. I want to have my Instagram, my Facebook, and my flyers. Or maybe I want to have four. I want to have my TikTok, my Instagram, my Facebook, and my flyers, right? Like actual mail. I'm going to create 4 centroids, saying I want to have 4 groups to target. Then what I would do is these centroids, when we initially do our, when we apply this model, it does 4 random centroids. So just 4, you see this blue, this yellow, this red, and this green. So what this model does, when we use this, it's called k-means is the model that we would use for this. When k-means does is we determine how many centroids. Then what it does is it says, okay, and it randomly places 4 centroids. Oh yeah, sorry. Wow, Winter, you are very fast. Good job. Cool. So what happens is it randomly places 4 centroids. Then it immediately, I don't know if you can see this, places 4 centroids. And immediately after it places 4 centroids, it attaches the data points that are closest to that centroid. So in this case, we've got all of these are closest to yellow. Only these 3 are closest to blue. Only these are green. And then red sort of dominates, right? And once it identifies which centroids are, or which data points are closest to which centroid, then what it does is it moves the centroid to where the majority of the data points are. So as we'll see, it'll start moving my centroid to where the majority is, and then it recalculates and says, okay, now which ones are closer? So you'll see these will start changing colors because it's re-identifying which data point is closer to which centroid. So here it keeps going, and then it gets to a point where now it's no longer, this is in the middle of these data points. It's no longer going to move. And we found what we call a stable solution. So blue started with only 3, but you see it ended up with all of these data points that are groups together, right? There's another example of this. Let's say we want to run another one and would say this one is like, okay, we're going to do TikTok, Instagram, Facebook, and flyers. Same thing. It does the 4 data points randomly. It associates data or centroids, sorry, 4 centroids randomly. It associates data points to that centroid. Once it does that, it takes that to where the middle of those, you know, of all its data points are. So this is going to come more this way, right? Because that's not sort of centered on those data points. And you can see it starts moving, moving, moving. Yellow takes over, green takes over. And then we get to a point of stable solution where, okay, these are the most similar. These are the most similar. These are the most similar. And these are the most similar. And now I can say, maybe this group, I look at that data in this group and maybe they're all in the teens. So I'm like, okay, this is my TikTok group. All of these data points are going to be targeted via TikTok. All of these data points are going to get targeted towards Instagram and Facebook and maybe flyers from the mail. Now, what would be a real life solution of this would be, another example is Instagram ads is really a solid thing, if we're being honest. If you've ever been on Instagram, if you are on Instagram a lot, oftentimes it's things that are sponsored or ads that you're like, actually, I really like this shirt, or I really like this tech tool, or exactly, Natasha, I'm a sucker for all the ads. So what's actually fascinating, I get really excited about this, is it uses this to take data points and take your profile. And it finds similar profiles using something like this clustering. And then what it will do, Natasha, is it will say, hey, this data point that is very close to Natasha, that is in the same group as Natasha, just bought this t-shirt. I think Natasha might like this shirt. And then it will give an ad for that shirt to you because somebody else that has a similar, basically like a profile, bought this shirt. Therefore, you might like it as well. And so that's how this like advertising will work, is it puts us all in groups and clusters after all the data that we've given it versus what, you know, how long we've looked at an image or what we scrolled on, XYZ. And then it will sell that data so that people can get shirts and sell shirts and tech tools and all that stuff, all through clustering, right? And this is a huge piece of TikTok, Instagram, Facebook, all is this, right? Because they're not trying to predict anything. They just want to see which profiles are similar, whether it's through political stances, whether it's through, you know, like hobbies, buying habits, page views. That's why cookies are a big, big deal, et cetera, et cetera. Any questions on clustering? Does that sort of help understand more of like the centroids and the clustering piece? Just target specific. No, Riley. So you're saying like this centroid is this? No. So you get a centroid, and then based off of that data, you would then determine, what are the similarities there. For questions. Cool. So that is an overview of machine learning from a supervised and unsupervised side. And just like that's just a basic general overview of machine learning, whether it was through AWS or Azure or GCP or just on your own. But now we're getting more in the Azure specific machine learning pieces. And so Microsoft Azure actually provides something called Azure Machine Learning Service. And that's a cloud-based platform for creating, managing, and publishing your machine learning model. So we create our model and then we publish it and we can utilize it. And we'll see how we do that here in just a bit. Now, these machine learning features, there's quite a few. There's automated machine learning. So what that does is, let's say you don't have a data scientist or you don't have any sort of expert in machine learning, you can actually create with data, right? You submit data and it creates an effective machine learning model from your data. So it actually can build that for you. Now, it's not as necessarily, what's the word I want to use here? Like it's more generic than maybe something specific that your company has. So if you're a startup and maybe you don't have a data scientist, this would be a great route because data scientists make a lot of money, right? And so maybe that's just something you don't want to incur. But if you want to get really targeted or something really niche, then this wouldn't necessarily do that. Then there's the Azure Machine Learning Designer, and this is a GUI, just a graphical user interface, which enables no-code development of machine learning solutions. So basically what you do is you would have somebody who submits your data, but they still have an understanding of picking which columns, picking what normalization tool they use, or which columns are normalized, which we'll talk about here in a bit. And so it's a no-code development piece, but you still have to have an understanding of how you do machine learning and what is the most effective. Then there's data and compute management. So it's cloud-based data storage and compute resources that professional data scientists use to run data experiment code at scale. So if I wanted to store some data or using compute instances, which just means that I'm using Microsoft's computer to actually process my data and run my model, I use that. And then I use pipelines, right? And that's something that a data scientist, software engineer, and IT operations professionals can define pipelines, which we'll talk about. We're going to have an example there, to orchestrate model training, development, and management tasks. So what it does is it creates a pipeline of when let's say I'm on Zillow and somebody fills out a form and says, I want to know how much my house is worth, right? Your software engineer is creating that. Then they're submitting it and it's going to the cloud. Then we're saying, I want to use a model to run this. And here's the model I want to use, to where then it spits out, what the user's house is going to be worth. So specifically for this Azure Machine Learning Designer, there was a big piece of this on the actual certification exam. So we're going to talk about it, and it's the drag and drop piece. And this is where somebody had asked at the beginning of this course, is it all multiple choice? And this is where it is a drag and drop piece, but we're going to go through that here. So again, Azure Machine Learning Designer allows us to use a GUI, graphical user interface, to drag and drop machine learning tasks to execute a machine learning pipeline. So we're creating and executing a machine learning pipeline. So in the steps, we're actually going to go over the steps of machine learning. So we've talked about the different types of machine learning, and now let's do the steps to create a machine learning model in Azure Machine Learning Designer. So in order to train and to deploy these models using Azure Machine Learning Designer, you need to compute on which you need compute. So I need actual power from my computer in which to run the training process. So I need to use the power from Microsoft's computer to run the training process and to test the trained model after deploying it. So I'm using Microsoft's computer in order to run that. So there are different types of computing. So you can manage compute targets for your data science activities. There are 4 types of compute resources: compute instances, which is a development workstation that data scientists will use to work with data; compute clusters, so scalable clusters of virtual machines for on-demand processing of experimental code. A virtual machine is basically like a server. Whenever you have a server, you can spin up a virtual machine, and it's like you have you're using a computer somewhere else, and you can use multiple virtual machines. So if I want to process a bunch of data, I can have a bunch of machines working on it versus just one that's really souped up with like RAM and CPU and GPU. You have inference clusters, which are deployment targets for predictive services that use your trained models. So once my model has been trained, right, then I'm going to have an inference cluster where I deploy it actually onto my website. That way I can use the predictive services of the model that I've currently trained. And then I have attached compute, which is links existing Azure compute resources, such as virtual machines or Azure Databricks clusters to that as well. So if I did want to utilize Databricks, we'll talk more about in the DP900 one. It's not necessary for right now. And virtual machines, again, that's like if I were to spin up, I have a Mac, let's say I needed to use a Windows, I could spin that up and choose a Windows OS. And now I have a Windows machine that I'm using, but it's really a server at the data center of Azure that, has that information on there. So when we're creating a machine learning model, we're typically going to use these two. We're going to use a compute instance, so we're something to actually run and train our model. And then once it's trained and we say this is a good model, then we are going to deploy our model using an inference cluster. So my first step, there's a bunch of different steps we're going to do. My first step here is to get my data. Before I can do any sort of machine learning, I have to get my data, and I can do that one of two ways. I can either import the data from the web, or I can import data manually. Let's say I have a bunch of data and I want to import it manually. That's okay. Or let's say I've got something from the web, or I already have a database on Microsoft Azure. I can import that as well and use that data to test and train my model. Once I do that, this is for supervised machine learning specifically. Once I do that, I need to specify my target or label column, right? What am I trying to predict? So here's an example of what the GUI would look like. In this example, we're going to do automobile pricing. So I want to predict, like Kelley Blue Book, I want to predict the price of a car. Here, I'm taking my price data, right, of all of the cars. My second step, first step is get my data. Second step is I need to do some data transformations. Now, if you guys have ever done anything with machine learning, you know that you have to clean your missing data, and you have to, and before any sort of machine learning, you can't have any like empty pieces. So you have to make sure you clean your data, make sure your data doesn't have any empty rows or columns. That way it can be used. And if it does have some empty rows or columns, then you can or empty columns, then you can make decisions on, do I drop that entire data point? Do I fill that in with the mean? So if it's like average miles per driven, you don't want to just like put that in the or miles on the car. You don't necessarily want to fill that in with like just an average, because it could be 150 miles and the average is 30,000, right? That's a large discrepancy. So you have to figure out how you're going to clean it. Then we do something called normalizing our data, and we select the columns. So like I was saying in our house example, right? I had to use square foot, bedrooms, and bathrooms in order to predict the price. So this, I might have a data set of a ton of different things, but we've talked about it, is I don't necessarily want to overfit my model. I don't need to use every single column, and not every single column is going to be important, right? Let's say that I am, let's take the car example. I am creating a model that is going to predict how much my car is worth. Well, maybe I've got all this data. I've got how many miles it's driven, how many miles per gallon it is, what year it is, what type, right? Who's the maker? And then maybe I have the previous owner. Now, that's not really important on my price, right? Like, unless I'm a famous person, unless I'm The Rock or Oprah, like, it's probably not going to affect the price. If it's just Will, people aren't going to pay more or less because it's me. So therefore, if I have that data, I might drop that column and say, I don't necessarily need that column to make a prediction, because it doesn't do anything, right? It's not going to affect my car price in any sort of way. So that's called feature selection, or more broadly, it's called featureization. That is selecting which features we want to use to train our model. Now, there also is something called feature engineering. And so let's say I've got data, and it is, like we said, we have how many miles are on the car, how many miles per gallon, how old the car is, what type it is, and what color, right? Those are my three things. But maybe I think it would be beneficial for my car to have an average miles driven per year, right? I have the total miles, and I have what year it was made, maybe there's not a column for how many or what the average miles driven per year is, but I might want to do some feature engineering. Means I make a new column, which takes basically how many miles, divides it by how old the car is, and then it imputes a number of what are the average miles driven. So then maybe if it's an older car, but it's only had 1,500 miles on average, well, that's actually pretty good, right? Versus, oh, it's a car that is 3 years old and it has 150,000. Like that's a really high number on average of 50,000 per year. That's sort of affects our price and what our car would be. So if we were creating this column that's not naturally occurring in my data set, but I'm using two features to make that, it's called feature engineering. And again, we can't have missing data for machine learning. So I have to either fill in the missing data or get rid of the row that has the missing data. Now it is on average, you don't want to get rid of more than 5% of your data. So if that is the case, if more than 5% of all your data is missing, then you want to try to figure out a different way, or more than 5% has missing columns. You don't want to just get rid of those. You want to try to figure out a way or say, hey, this data set's actually not good enough for me to train on. Because data is really, really valuable. And the last one is doing something called normalizing my data. So many machine learning models are what we call distance-based. Means that it will learn patterns in the data based on data that is close in space. Now, what does that mean? Well, let's say that I've got a car. I'm going to annotate here. Let's say I've got a car and it's got 30 mpg. And then it's got 50,000 miles. Oops, I don't know why that went high. Well, when it says distance-based, it doesn't look like we wouldn't have the MPG. We would just have that in my column name. So we just have the number 30 and it had 50,000. And when it says distance-based, it means it holds more weight to higher numbers. And so it associates weights in our model to each column. And if this number is higher, right, then it's going to say that that's more weight than miles per gallon. But we know that that's not true, right? That we want them to be on an even playing field. So we can do something called normalization. And normalization is where we take the highest, let's say I had miles per gallon, I had 15, 20, and 30. What I would do is when I normalize my data is I would take this column of miles per gallon and I set these numbers to a scale of 0 to 1. So I've got, this would be 0, meaning my lowest is 0. And then my highest is number 1. And then I associate numbers here in comparison to 0 and 1, and in association to this, where it lands on the 0 and 1, where this might be like a 0.45. I would do the same thing with miles. Maybe I have one that's got 20,000, 40, and 60,000. What this would be is this would be associated to a 0. This would be associated to a 1, and this would be associated to a, let's say, 0.5. To where now the numbers in my column are 0, 1, and 0.5. They're all between 0 and 1. So now there's not a weight, an extra weight added to this column, just because these numbers are going to be higher, right? Miles on a car are always going to be astronomically higher than maybe miles per gallon when we're dealing with like a gas-based car. Does that make sense? So normalization is making sure that these are all in the same playing field and that my model doesn't automatically put more weight on miles just because this number is higher, or horsepower or something of that nature. Any questions on normalization? Cool. So features with larger units can artificially distort this. To avoid this, we normalize our data. It's called a min-max scaler. So we typically scale our data between 0 and 1, where we take the minimum that goes to 0, 1 that goes to maximum. Cool. So I've taken my data, I transformed my data, I've added those data transformations. Here's just an example of if I'm selecting my features that I want to use, maybe all of my columns from my data set is right here, and I want to choose or they're right here on these available columns, and I'm choosing every single column that I think is going to be good for my model. I can also select the pieces, the columns that I want cleaned, right? And normalized. So I can do that as well. So like, okay, I want my horsepower to be normalized. Or sorry, that was this one. This one was to clean my data. So if I wanted to clean that, make sure I do that in a certain way. And I set with rules. And so I can say I want the average, or I want to do something there. I want to replace that with, some number. And this is the one that I normalize. So I have miles per gallon, highway miles per gallon, peak RPM, length, wheelbase. I want to make sure that these are not artificially weighted, because, horsepower is much larger than probably highway MPG, right? So I want to make sure that that is completed. Cool. Then I'm going to do something called training my model. So where I train my model is the process of allowing our model to detect and view patterns in my data set. And this involves a couple of steps, because let's say I've got data and that's 100% of the data I have to work with. Well, what I want to do is I actually want to split my data in what we call a training and a validation set, or it's called a test train split as well. You might hear it that way. But it's called a training and a validation set, where I take 75% of my data and I train my model on that. And I leave the other 25% to test later on to see how my model does on maybe data that it hasn't already been given. Because what we want is our machine learning model to be at a high rate of prediction to new and unknown values, right? To whenever somebody comes and prices out their house, I might not already have that data, and I want it to be new and unknown to where I can make an accurate price for that. So the way it would do that is we hold out some of our data, so I can do something called evaluation to say, okay, this is how it acts and is trained on data that it's already seen. How does it evaluated compared to data it hasn't already seen? How are those different? And what do I need to do in my model to actually make that a more accurate number? So I've trained, I've done my test train split, where I have split my data to 75 and 25. Then I decide which module I want to use. This is which machine learning model, right? The actual algorithm I want to use. For regression, we have something called linear regression. So from an Azure perspective, when I'm dealing with any sort of regression problem, I'm going to use linear regression. Now, this is confusing, and I hear this, but it's just something you have to memorize. When I'm dealing with a classification problem, I'm going to use something called logistic regression. Now, I know that the name regression is in there, and you would think regression goes in the regression problems, but for classification problem, we use something called logistic regression, where that basically uses linear regression, but then adds this thing called a sigmoid function, where it creates a probability of which group it's going to be in. So if I do have a classification of, diabetic or not, I would use this, and it would create a probability of, this is diabetic, or this person is diabetic, or they're not. And then lastly, for our clustering, we have the k-means. That's what we visually saw. It's just k-means clustering. That's what we use. So just remembering the different training modules. Logistic regression is a classification. Regression uses linear regression, and the clustering is k-means. Here's how linear regression works. It is, as you see, it's a linear regression model where I've got data points and I have this regression line, and it happens linearly. So linearly. So that's how that model works. And then again, this logistic regression returns a probability between 0 and 1 of being positive, meaning that it is in this group of 1, or 0 if it is in this group of 0, right? So probability that it is, if it's got a 12% probability rate of being diabetic, that would put it in the group of not diabetic, sort of thing. Now, this is typically used for binary classification problems, meaning that there's one of two groups, diabetic or not. You can use it, logistic regression, for multiple groups, but there's a little bit of tweaking that has to happen. But just know that, especially for this certification, logistic regression is a binary classification problem, meaning it's one of two groups. They're diabetic or not. It's cancerous or not, something of that nature. And we've actually already talked about k-means clustering and how it continues to do that to where it gets to a stable solution. So this is visually what we saw. placing centroids randomly, it going to the center of where those different data points are, and continually doing that until it gets to a stable solution. And so the last thing we do, or not the last thing, sorry, is we then train our model, we add that, and then we score it. So a model is trained, cool, we've run it, now we score our model. And this involves seeing how well our model performs on the validation set. So we do have, when we have this set, it would be data, right, that we already know the answer to. So I know how much the car is worth, and I'm training it on that. So it's saying, okay, for this car that is 10 years old, that has 50,000 miles, we know that the price was, you know, $20,000, right? So it trains it on that. And then we can choose, and then we see how well it performs, right? How well it knows and how confident it is in that. And then what we do is we score our model. So we train it, then we score it on the data we have held aside, right? And so we say, okay, how well does it perform on data it hasn't already seen before? And that's how we can tweak our model to make it the most efficient that we can. We can also use, from a classification standpoint, we can also use a process called cross-validation that involves iteratively picking new, or sorry, this is something different. So we can use a process called cross-validation, which involves iteratively picking new validation sets and scoring our model on each of these validation sets to see how our model performs on unseen data sets. So instead of just having one test train split of this 75% tested and this 25% or 75% trained, this 25% tested, it sort of scrambles those and continues to do that. So that way it can get, you know, now, so it does that first one, and then it reassigns the 75-25 split to new values, right? And then it just continues to do that. It's called cross-validation, where we're training our model consistently. And this is what it looks like. I know there's a lot of information right now, but we take in our data, we select the columns we want to use. This is our data transformations. We clean it, we normalize it. We split it into my test train split, and we pick which type of module we want to use. This is a regression problem, therefore we use linear regression. We train my model. Then we, after we train it with the training data, right, using our linear regression, we score it based on, okay, I have my trained model. We introduce the data that we've set aside to test it on. We've introduced that and we score it. And then lastly, we want to evaluate it. So we score it basically saying, okay, here's my model. Here's my new data. How is that doing? And then we evaluate that different metrics. So we take these different evaluation metrics to see how good of a job our model did at correctly predicting our target. And there's a ton of different metrics we can choose from. For regression evaluation, so from a number perspective, we take the mean absolute error, meaning it's just the difference whether it was, if we're predicting car price, whether it was 5,000 over or 5,000 under, the absolute error is just 5,000, right? It was off by 5,000. So we can take that, the mean of that. We can take the root mean squared error, where similar to the mean absolute error, but it actually squares the differences between the predicted and the true values. And then what it does is it actually penalizes larger differences. So a larger difference indicates greater variance of the individualized errors. So that's a great one to know. There's coefficient of determination, which is R2 or R squared, sorry. Summarizes how much of the variance between the predicted and true values is explained by the model. So the closer to one, the better the value, the closer to one this value is, the better the model is performing. So if we have a really high R2, like a 0.98, that's a really high R2, which says that our model is performing really, really well. Now, from a classification evaluation, those other ones were regression. From a classification standpoint, we use something called a confusion matrix. So it's a tabulation of the predicted and actual value counts for each possible class. So let's say we have two, right? Diabetes, they're either diabetic or not. We will say, okay, these are my true positives. We predicted positive and they're actually positive. Then we have false positives where we predicted positive, but they're actually negative. Here I predicted a negative, right? But it's actually positive. So this is a false negative. and this would be a true negative, right? So here is, we predicted negative, 0 represents negative, 1 represents positive. 0 is what I predicted, and then that's what it actually is. So this is my true negative and my true positive, false positive, false negative. Think about this with like COVID tests, right? That's a big thing right now, is false positives, false negatives, same sort of thing. So we can predict, use these to train and say, is this accurate or not? And when we have those, when we have these confusion matrix, I can then from that say, okay, what is the accuracy, precision, and recall? Which accuracy is the ratio of correct predictions, so my true negatives and my true positives, to the number of total predictions. So how much did I basically get right? Of all my predictions, how many of them is right? Precision is basically out of all of the fraction of positive cases correctly identified to the true number of positive cases. So in this case, like, in other words, out of all patients that the model predicted as having diabetes, how many are actually diabetic, right? Of all of the ones that we predicted has diabetes, how many are actually diabetic? That'd be called precision. And the recall is the fraction of the cases classified as positive that are actually positive. So the number of true positives divided by the number of true positives plus false negatives, meaning that they were positive, but we said that they were negative. So it's basically the number of true positives. So in this case, it would be 869 divided by the number of true positives. So this plus false negatives, which is this. So these guys, so 869 divided by 869 plus 342 would be how we do recall. You can also do F1 score. So if we did something like logistic regression, F1 score is an overall metric that essentially combines precision and recall. And then the AUC is the area under the curve. So whenever I use logistic regression, it creates sort of like this S. And then I usually thought we had something that shows, but the AUC would just show you anything under the curve. It's just a way that we can evaluate the model. One thing to know is if you do use AUC, this is a question on the exam. If you use an AUC is lower than 0.5, so if your AUC number comes out as lower than 0.5, your model is actually worse or performing worse than if you were to randomly guess. So if you have a 0.3 or 0.2, then your model is actually performing worse than your actually guessing. So you'd be better off randomly guessing than using your model. And that was a question on the exam. So like if it has a 0.35, is that better or worse than randomly guessing? That would be your question. And then from like an unsupervised perspective, we do have some evaluation metrics we can use to measure how good our clusters are. But that's really sort of mathy, and we don't necessarily need to deal with that, especially for this model. So in conclusion, we take in our data, we select the columns we want to use, we clean the missing data, and we normalize the data. That's called our data transformations. These three are called data transformations. We split the data. We use linear regression. We say, okay, this is a regression problem. I want to use that. I train my model. I take my trained model and I score it on the data that we saved to be tested on. Then I take that output and I evaluate my model based off of one of those evaluation metrics. And then lastly, after it gets to a point where, okay, we've done it the way we want it. Our model is good. We have trained it. It is ready. Then I create an inference pipeline. That way I can actually put it on our website to where here, let's say we have Zillow, a user takes web service input, or I can enter data manually, but they input it. I then select columns and data set, and then I use my model to clean my data, right? Apply my transformation. So it selects the columns for me. It applies the transformations the way that I've said, if this is missing, this is how I want you to handle it. I normalize my data here. I use my trained model to on my actual data, I score it, and then I give my output to what their house is worth. So that's what's happening in the background if you're using AI in the actual cloud. Any questions on that? That was a ton of data. Any questions on that?
You're saying on the question, there's a question on the area under the curve. And then, so I'm guessing one on the area under the curve is the models predicting is really good. And then you're saying that
And the
0.5,
AUC.
it's just essentially random data.
Yeah, yeah. So 0.5 would be worse than random, actually. So if I were to randomly say, like this person has diabetes or not, from a probability standpoint, if you're to use your model on 100 people and I randomly said yes or no, I would actually likely perform better from a randomization standpoint than what your model is at predicting if they have diabetes or not. That's what that is saying.
Okay.
So anything under 0.5 is your 50%, right? They're either in or out from and this is a binary, so a 0 or 1 sort of thing. Either they have diabetes or they don't. That's what so right, it's like a 50% chance, heads or tails, something like that. Cool. Great question though. Any other questions? Somebody asked, how customizable is the models in Azure? Does it come with any templates to get started with for common use cases? So it depends on what you're using. This is all in the machine learning designer that we create the model. Now, again, remember there is Azure tools that it can actually do that for you. So yes, if you did want to have common use cases, or if you had something that was pretty simple and you didn't necessarily have all that data or anything to train it on, Microsoft Azure does already have that for you. So it can do that, which is cool. You're going to see there's a ton of stuff that we could do, but Microsoft's already done it for us, which is awesome. Cool. So it's lunchtime now. I'm going to put this here and we'll go through this after lunch. The reason I do this, I'll put this in the chat for you. The reason we do this specific one is this is similar to what it looked like on the exam. Now, the exam won't have all of them empty. It will have a couple of them empty, and then maybe there's 3 that are empty, and it'll say, drag and drop what these in the correct area. So if I were to do this classification, what's the first step? Maybe the first and second step are given to me, but this one is empty. Oops, sorry. But like maybe this one is empty and this one is empty. So feel free to try this on your own. Right now, what you'll have to do, because this is view only, you'll do file and you'll do, oh, that's weird. I don't know why I did that. Okay. So you'll have to file, make a copy, entire presentation, because you can't edit this. And then in class, we'll come together and put these together. Cool. Any questions before we break for lunch? That was a lot of information. That was the most difficult part. Just so you guys know, the afternoon is my absolute favorite. We go through computer vision. We go through NLPs. You can see really some power, and it's really, really fun. You can see a ton of stuff. And I'll tell you about a program that I built or building that just utilizes this really, really simply and really, really easy to implement. It's kind of fun. Cool. I'll pause the recording here.